Good afternoon, everyone. We are Stony Brook University's 3D printing team. I'm Fiona, the project manager.
I'm Joy, the CAD captain.
I'm Andres, the structural captain, and we're here to present the bridge that we decided to do for the 3D printing competition. We decided to take inspiration of the Hellscape Bridge in New York City. The Hellscape Bridge has a specific principle of transmitting the loads through a cable, an arch type system. So it transmits the loads from a cable all the way to an arch, which does later transmit the loads efficiently to the base of the bridge. We specifically took inspiration of the Hellscape Bridge because it transmits the loads up to the cables and then it transmits up to the arch, the truss structure. Based on the truss structure, we can use the two different arches, and then the arches will allow us to transmit loads more efficiently. After we decided on the main prototype and we tested it out, we went through different iterations and we decided to heavily incorporate more infills into the main areas of the bridge that would activate the more load as possible. Based on that, we also decreased different areas like the side panels, and on the bottom of the bridge, we also decrease the area on the bottom of the deck, so we only have the specific parts that will transmit the most load efficiently. We also specifically also worked on the connections.
So going more in depth on the connections, we had two different types of connections to interlock the individual pieces of our bridge together. The first type of connection was a dovetail, which is what you see along the entirety of the arch. We decided on a dovetail because dovetails are self-interlocking, so the more load you apply on them, the tighter it wedges together, and that basically reduces any risk for lateral pulling or the deck simply pulling out. The second type of connection we had was a rectangular channel connection along the edges of the deck. This basically allows for the deck pieces to simply slide into the arch, kind of like a rail and a groove system. In addition to the connections, we also had to think about the overall geometry of our bridge as well as how the pieces fit together. So for this design process, we mainly prioritize reinforcements, and an example of this would be where we cut our deck and our arch truss pieces. So even though our entire bridge was split into 3 sections, we placed the cuts for the deck and the arch at different locations, kind of staggering the joints in a way. And this basically creates a doubly reinforced bridge where at points where the arch is cut, the deck is continuous and vice versa. This allows for extra support and for the overall load to be more evenly distributed. And in addition, we also had cuts on our deck as well. We had interlocking plates that overlap when the entire model is assembled together, and that is what helped give our bridge that big continuous deck. For all of these connections and pieces, we also did multiple test iterations to figure out what offsets would work best for assembling the bridge together. For our dovetail connection, we landed on 0.064 millimeters of offset, and this was a pretty snug fit. And for the rectangular channel, we had a final offset of 0.102 millimeters. Even though this was slightly looser than the dovetail connection, that extra clearance allowed for a more smoother fit of the deck.
And here we have our final print design and some technical print details. So the 3D printer that we used was the Bamboo Lab P1S. And here we also have listed 2 of the characteristics for our prints. So just like the nozzle size and the nozzle temperature. And we also have the 2 different filament types we used. So the first one we used for our side arch was a gradient in a mint lime color, and then for our deck we used the bamboo green. Alongside, we also have the density, tensile strength, and the bending strength of our material. So here we have the number of wall loops we use and the infill densities. So for the pattern, as previously mentioned, we use the gyroid pattern to account for the load being transferred in all directions. Specifically for our design, we decided to keep a wall loop of 4 for the side arches, while for the middle piece we reinforced it and increased it to 5 to account for the load being loaded in the center. We also want to mention that for our previous test loads, we always saw failure at the connections, so we decided to increase the infill density there to 30%, and that really helped with reinforcing the load and allowing us to maximize. And we would like to, this is our team structure, and we would like to thank our civil engineering department for helping us throughout this design process. Thank you guys for your time.
Right on. So I wanted to ask, so you mentioned using 2 different shades of green. You've got green gingham in the background here, and some, I guess, like a vegetable and herbal theme. So what was the inspiration for this?
So actually for our concrete canoe team, the theme this year is peas in a pod. So usually the other design teams would kind of like bounce off of that. So we kind of just went on with the green theme here.
Okay, that's so cool.
Adding on to the color, we did use 2 different materials properties, and that can because of the different material properties. We had, and locally they were both green, so it was great. But the bottom deck had more bending, allowability on it, so we specifically decided it so it actually, yeah.
So I see it here on the right side where you actually, did you measure these material properties for these filaments?
No.
Okay, they're reported.
Yes.
Okay, cool. So, but you use those as a reference for where you should put different.
We also
materials.
did test some test out parts of it, especially considering the infills, but mostly came from the actual knowledge of the material.
But great job using the material properties. I guess I appreciate how you give recognition to all the team that helped you, including those who aren't here, your advisors. I wanted to ask about the vertical members. So one team had removed them, and what was your experience with these? So I think you mentioned these you had to make thicker. Is that right? Or because you're inspired by Hell's Gate, so you've got these cables that are basically transferring the load to the arch. So
it was mostly based on iterations. We first decided to go with a very heavy bridge. Our first bridge was heavy, so we decided to just like go with what would be the most safety wise minded, and then be able to like cut off based on like similar like principles of like construction. Be like, be able to follow what would be like the best safe environment, and then be able to like not compromise, but be able to like be more efficient on the way that the loads are traveled and how much material we can actually use on the bridge. So this will be the initial thickness that we initially came up with, and based on the SAP models and based on everything that we kind of came up with, we were able to decrease other parts of the bridge.
Excellent.
Just to add on to what he said, so initially our thicknesses were the same for all the vertical members, but after some more analysis, we decided to decrease the thickness for our 2 side members.
Okay.
So you guys have different infill. Yeah, go ahead.
Yeah, you go ahead.
You have different infill densities in the same bridge.
Yes.
Can you point to where the thicker, like 30% density is, and why is it like that versus 10%?
So actually throughout our whole side arch, it is 12% infill, and then just at the joints, because we always saw failure there, we decided to reinforce it and increase it to 30%. Also for our deck, the side pieces are 10, while the middle is 15. Well, with the same ideology.
And about how many iterations would you say that you went through? And I'm sorry. And
No, that's okay. You can go ahead.
sorry about that.
It was 5. Yes.
Approximately. And we test loaded around 3.
Okay.
2,
Excellent.
yes.
Excellent. And
So in a 3D printer, how do you transfer the material to make the actual bridge? Is it in form of small pellets or like this?
So for the printer, we use the filament. So it usually comes in a roll, and we kind of just load it into the printer, and it kind of just comes out as like the plastic.
Yeah. It comes out as layers on the sheet. It actually came through some of the issues where we were test loading some parts. Depending on the way that we had to optimize what way would be more efficient to actually print it, if it could bring more information based on the sports.
So essentially it comes in like wire rooms.
Yes.
Okay.
That's a very good question. When you need to use powder is when you're working with metals. And I talked to our makerspace head the other day. They are very scared to use it because anytime you change the filters, when you use a metal 3D printer, it deposits these basically oxygen-free deposits of metal on the filters that once they touch oxygen are ready to explode and combust. So it's very dangerous, and he said everybody in that space has burns. So they really try not to change the filters or the metals that they're using as a result. Great presentation, thank you.